A landslide can be defined as the mass movement of Earth's downslope. It is a rapid slipping of a mass earth or rocks from a higher elevation level to a lower elevation level under the influence of gravity and a water lubricant. It described a wide variety of processes that results in the downwards and upward movement of slope forming materials like rocks, soil, artificial fill or a combination of these. The materials may move by falling, topping, sliding, spreading or flowing. It is due to the offshore, onshore and the coastal environments. The main driving force for a landslide is due to the action of gravity. Types of landslides. Basically, the landslides are of two types. One is very slow flow and very high flow. Flows means flows are a spatially continuous movement in which surface of shears are short lived, closely spaced and usually not preserved. These are classified on the basis of materials and the speed. They travels into two categories. The first category is known as very slow flow, where soil and rocks can move by less than 16 millimeter per year. The second type is known as extremely rapid flow. This can move to over 5 meters per second. This process occurs naturally and can be sped by human processes including forest clearance. Landslides are divided into 5 categories. The first category of flow is debris flow. A debris flow is a form of rapid mass movement of land in which combination of loose soil, rocks, organic matter, air and water mobilize as a slurry that flows down slope. It is a very rapid to extremely rapid. That means, the flow velocity is greater than 5 meters per second at the angle of 20 to 45 degree. It causes due to the high rainfall intensity. The second type of flow is debris avalanche. Is a type of the slides characterized by the poetic movement of rocks, soil and debris mixed with water or ice. Sometimes water or ice also mix together. Debris avalanche is a very rapid to extremely rapid shallow flows of partially or fully saturated debris on a steep slope without confinement in an establishment. The angle of the slope is the same as the debris flow, that means 20 to 45 degree, and it is also due to cause high rainfall intensity. The third types of flows of landslide is earth flow. This has a characteristic feature is hourglass shape. The slope material liquefies and run out, forming a bowl or depression at the head. The flow itself is elongate and usually occurs in fine grained materials or clay bearing rocks on moderate slopes and under saturated conditions. Intermittent flow like movement of plastic clays, earth, here the speed of the flow is greater than 1.8 meters per hour. Here the slope angle is 5 to 25 degree. Fourth category of flow is mud flow. A mud flow is an earth flow consisting of material that is wet enough to flow rapidly and that contains at least 50% sand, silt and clay sized particles. It is a very rapid to extremely rapid flow with greater than 5 meters per second velocity, and the angle is 20 to 45 degree, and it is also caused due to high rainfall intensity. The fifth classification of the flow is known as creep flow. Creep is the imperceptibly slow, steady, downwards movement of slope forming soil or rocks. The movement is caused by shear stress sufficient to produce permanent deformation, but too small to produce shear failure. Creep is indicated by curved tree trunks, bent fences or retaining walls, tilted poles or fences, and small soil ripples or ridges. Now, the second category is the slides. A slide is a downslope movement of soil or rock mass occurring dominantly on the surface of rupture or on relatively thin zone of intense shear strain. A slide develops where a crack forms at the top of the slopes. Slides are of three types. The first one is rotational rock slumps, second is translational debris slides, and third is earth block slides. Third category is spread. Spread is defined as an extension of a cohesive soil or rock mass combined with a general subsidence of the fractured mass of cohesive materials into softer underlying material. This types of landslide involves sudden horizontal movement on very gentle terrains. It is often initiated by earthquakes that liquefies the layer below the moving materials. Fourth category is the topples. Topples involves rocks or soil that tilts and or rotates forward on a pivot point. There is not necessarily much movement, however, it may lead to fall or slides of the displaced material. Toppling is sometimes driven by the gravity exerted by material upslope of the displaced mass and sometimes by water or ice in cracks in the mass. The fifth category is known as falls. Is a complex movement of materials on a steep slopes including rocks or soil which detached from the slope and moves rapidly to its new resting place. It is associated with undercut cliffs and river banks. The speed for the falls will be from very to extremely rapid and maybe happen in just a second. The leaning soil that we call slope is start from 45 degree to 90 degree incline. This is the main difference between all the types. Fall is happen when there are vibrations, undercuttings, differentia, weathering, excavation or stream erosion imposed on the slope. In the literature, there are only the 5 classification of landslides, but sometime it may be due to the combination of all these, maybe the 2 or maybe the 3, then it is called as a complex type of landslides. Causes of landslides. Landslides occur when a stability of a slope changes from a stable to an unstable condition. A change in the stability of a slope can be caused by a number of factors acting together or alone. The main factors, one is the natural causes of landslides and sometime it may be due to the man-made activities. Natural causes of landslides includes groundwater. In groundwater there is a pressure acting to destabilize the slope. The second cause is loss or absence of vertical vegetative structure, soil nutrients and soil structure. The third cause is the erosion of the toes of a slope by rivers or oceans waves, weakening of a slope through saturation by snow melt, glaciers melting or heavy rains, earthquakes adding loads to barely stable slope, earthquake caused liquefacions, destabilizing slopes, and then lastly volcanic eruption. Human causes includes deforestation, cultivation and construction which destabilize the already fragile slope. Vibration from machineries or traffic loads, blastings, earthwork which alter the slope, the shape of the slope or which impose new loads on an existing slope. In shallow soils, the remove of deep rooted vegetations that bind colluvium to bedrock. Construction, agricultural or forestry activities like logging which change the amount of water which infiltrates the soil. Landslide factors. The first factor is the ground conditions such as sensitive materials, collapsible materials, weathered material, sheared, jointed or fixtured materials. The second factor is the geomorphologic process such as erosion of the lateral margins, subterranean erosions means solution piping, vegetation removal. Physical process such as intense short period rainfall, earthquakes, volcanic eruptions, shrinks and weathering of expansive soils. These factors are due to the natural causes, and the other factors is the most important factors which is due to the man-made process such as excavation of a slopes or a toes, loading of a slopes or a crest, drawdowns of reservoirs, defective maintenance of drainage systems, vegetation's removal. The hazards from landslides can be reduced by avoiding construction on steep slopes and existing landslides or by stabilizing the slopes. Stability increases when groundwater is prevented from rising in the landslide mass by covering the landslides with an impermeable membrane. Secondly, directing surface water away from the landslides. Third, draining groundwater away from the landslides, and lastly, minimizing surface irrigation. Slope stability is also increased when a retaining structure and or the weight of a soil, rocks, burn are placed at the toes of the landslide or when mass is removed from the top of the soil. However, landslides can be maintained with modification of slope geometry, drainage, retaining structure and internal slope reinforcement. Now comes to the management practices. There are three practices we have to adopt during the landslides: before the disasters, at the time of the disasters and after the disasters. First, before the disasters, we should become familiar with the land around you. Learn whether landslides or debris flow have occurred in your areas by contacting local officials, states, geological surveys and other departments of natural resources. Slopes where landslides or debris flow have occurred in the past are likely to experience them in the future. Second, you should take support your local government in efforts to develop and enforce building ordinance that regulate construction in areas susceptible to landslides and debris flows. Buildings should be located away from known landslides. Debris flows, steeps, slope, streams and rivers, intermittent stream channels and the mouth of mountain channels. Watch the hillsides around your home for any signs of land movements such as small landslides or debris flow or progressively tilting trees. Contact your local authorities to learn about the emergency response and evacuation plan for your areas and develop your own emergency plan for your family and business. Secondly, at the time of the disasters, if inside a building, stay inside, take cover under a desk, table or other piece of steady furniture. If you are outdoors, try and get out of the path of the landslides or mud flow. Run to the nearest high ground in a direction away from the path. If rocks and other debris are approaching, run for the nearest shelters such as group of trees or a building. If escape is not possible, curl into a tight ball and protect your head. Thirdly, after the disaster, stay away from the slide area. There may be a danger of additional slides. Check for injury and trapped persons near the slide areas. Give first aid. Remember to help your neighbors. Listen to our battery operated radios or televisions for the latest emergency informations. Remember that flooding may occur after a mud flows or a landslide. Check for damaged utility lines. Report any damage to the utility company. Check the building foundation, chimneys and surrounding lands for damage. Replant damaged ground as soon as possible, since erosions caused by loss of ground cover can lead to flash flooding. Seek the advice of geotechnical expert for evaluating landslide hazards or designing corrective techniques to reduce landslides risk. Areas that are generally prone to landslides: existing landslides, steep natural slopes, particularly in weak geologic materials, steep construction related cut or fill slopes, areas in or at the mouth of drainage, slopes below leaking canals or ponds, develop hillsides where septic tanks, soil absorption systems are used and landscapes are irrigated, below cliff or hills with outcrops of fractural rocks. Now come to the major landslides in India from 1990 to 2005. The first is in October 1990 in Nilgiris Hills, 36 people killed and several people are injured. Several buildings and communications networks are damaged. The second disasters in July 1991 in Assam. Here 300 people were killed, road and buildings are damaged. In November 1992 is again in Nilgiris Hills. In June 1993, as a whole 4 persons were buried. July 1993, Itanagar, 25 people buried, alive 2 kilometers road damage. In August 1993, Kalimpong in West Bengal, 40 people killed, the heavy loss of property is there. In August 1993, Kohima, Nagaland, 200 houses were destroyed, 500 people died, about 5 kilometers road stretch was damaged. in November 1993, again in Nilgiris. Here 40 people were killed, property worth several lakhs damage. In January 1994, Kashmir National Highway severely damaged due to the landslides. In June 1994, Varund Ghat, Konkan coast, 20 people killed, breaching of Ghat road damage to the extent of 1 km at several places. In May 1995, Aizawl, Mizoram, 25 people killed, road were severely damaged. In again June 1995, Malori, Jammu, here the 6 persons were killed and the roads were damaged. In September 1995, Kullu, 22 persons killed and several injured, about 1 km where road were destroyed. In 14 August 1998, Okimat, here the 69 people were killed. In the same month and in the same year, that means 18 August 1998, Malpa Kali river, here the 205 people killed, the road network to Mansarovar is disrupted. In August 2003, Uttarakashi, heavy loss of infrastructure is take place. In July 2004, Joshimath, you heard the name Badrinath, heavy landslide hits, Lambaghar areas washed away, and nearly 300 meters long road between Joshimath and Badrinath were destroyed, and here 17 people were killed. In August 3, 2004, landslide at Tehri Dam, and here the 9 people were killed. Now comes to the historical landslides of world. The Goldu on September 2, 1806, the Cap Diamond Quebec roadslide on September 19, 1889, Frank Slide, Turtle Mountain, Albert, Canada on 29th April 1903. In 1949, on July 10, Khet landslide, Khet, Tajikistan, Soviet Union. The next disasters take place in Monte Toc landslides. The length of this landslide is 260 million cubic meter, falling into the Vezon Dam basin in Italy, causing a mega tsunami and about 2000 casualties on October 9 in 1963. Now, we have to always take precautions during the landslides, and we have to avoid the landslides. Do not make a heap of the landslides. The water, the level of the water, the level of the muds should be in a uniform manner.